Okay, let's try to understand this tree data structure in this whiteboard. So we will try to draw this tree and everything so you'll understand better. So tree is our topic. Okay, now in this tree data structure, tree can be, okay, I'm going to create what? I'm going to create this tree generally. So how, tree is done and everything, I'm going to do that. Okay, suppose I want to copy this, I'm going to create this tree, paste it here. Okay, paste it here, then paste it here, paste it here, paste it here, and one more. Let's suppose this is there, and one more thing I'm going to take, maybe because it's a normal tree. All right, so I'm going to take it here. Okay, so what I'm going to do is I'm going to connect this with this. So this is the, maybe, parent, this is connected. All right, maybe this is connected with this, and this is connected with this is connected, this is connected here, and this is connected here. So this is a normal tree, so I'll give the value also, maybe. All right, that is 10, all right, 20, 30, 40, 50, 60, 70, 80. So one node you can see that is connected with what? That is, this node is connecting with 1, 2, 3. So this is an, at most, if you make this a tree as a trinary tree, so it's going to connect at most 3. So if it is connected with n number of nodes, let's say, here one more node also connected, here one more node is connected, all right, so that's going to be an n-nary tree, n-nary tree. All right, so that's an n-nary tree. Right now, okay, we know that we're going to learn about binary tree. So tree is a non-linear data structure. In non-linear data structure, what you're going to do is, okay, we're going to learn, most importantly, there's going to be binary tree, trinary tree, lots of trees are there. We're going to learn about binary tree. Binary tree. Okay, now what is going to be there in binary tree? We're going to bifurcate all those things now. All right, for that I have to create a binary tree, and in binary tree we already learned the definition that a binary tree can have at most 2 nodes that's going to be connected. All right, let me copy it and paste it. Now we're going to create a binary tree for you guys. Binary tree can have at most 2 nodes. See, at the most 2 nodes we have taken, right? So let's suppose this is being connected over here. Okay, this is connected over here, this is connected over here, this is connected here, this is connected here, this is connected here, and this is connected here. So one thing you can see that if this is 10, 20, these are the data, 30, 40, 50, one mistake I did, that is 10, 20, 30 is going to be 40, 50, 60, 70. All right, these are the elements there, and we say this is what? This is level 0. This is level 0. This is at level 1. This is at level 2. All right, now this is what? This is root node. This is root node. Okay, this is what? Right child of 10, and this is left child of 10. Right, okay, similarly, okay, at the last we're going to create such a way it's going to be pointing that whatever the leaf node that is going to be there, that is going to point to the null. That is, left pointer and right pointer for every leaf node is going to be null. We're going to write that code such a way. Okay, right now we are setting up, so I'm going to show that all the things. Okay, is going to be null. For 70 also it's going to be null, and for here also it's going to be null. Now this 40, 50, 60, 70 all are what? These all are leaf node. This is a leaf node. A binary tree can have at most two, node connected. See, this 10 having at most two, not more than that. 20 is going to, so it can have one, it can have zero. The leaf node have zero. You can see it can have one. Okay, it can have two, but more than two in binary tree, any node cannot be connected. So that's not going to be binary tree. All right, this is there. Then we talked about what? This is okay. 50 is also leaf node. 60 also leaf node. 70 is also leaf node. I'm not writing everything. All right. So if I try to say this is an sub tree. Similarly, this is also an sub tree. Similar to sub array we did, right? This is also an sub tree. All right. This much is clear. Okay. So a node can have left child and right child, and node that share a common parent are called as sibling, that we already talked of, right? So here what I'm going to write is point number 1, a node can have left child and right child, and nodes that share a common parent are called as siblings. That we already talked about. Okay. Second thing is, we talked about height of the tree, and we talked about depth of the node. Okay, and we talked that a binary tree can have only at most two nodes. So I'm going to write that point also. That one thing that is there in closing this, that is what? Okay, let me take the text so it would be well. Okay, what I'm going to write is, in a binary tree, the parent in a binary tree, all right, in a binary tree, okay, parent node can have less than or equal to two nodes. It can have zero, node, or one node, or two node. This is there. Let me change the color of it. Let me make it okay. This is the one binary tree that is there. One point is there. All right, that it can have one thing. I'll do then, I will try to delete these things and write this in a binary tree. So this is the first point. This is point number 1. All right, that a binary tree can have two nodes, at most two nodes, and at most it can have two nodes. All right, what is the second point we wrote? Second point we wrote, that is dot a node can have left child and right child, and nodes that share a common parent are called as siblings. All right, now third point would be, we want to write it about the height of the tree one, and we're going to write the depth of the tree. All right, then what is the thing we're going to do for that? All the tree elements, what are the operations that we're going to write after that? So height of a tree, that is height of a tree, right? So the height of a tree, of a binary tree maybe, or a binary tree is the length of the longest path from the root node to any leaf node, to any leaf. One more thing I said, that the height, the height, the height of an empty tree is considered as -1. That I already talked of. All right, these things are there. One more thing that is there, that is as the depth of a node. Fourth point is going to be depth of a node. What is depth of a node? So the depth of a node in the binary tree is the length of the path, not the longest. Longest is the height, right? Path from the root node to the, I would say, to that node. That node. So the depth of root node is 0. This is the few points that you're going to write for the binary. All right, let's move ahead with the topics. That what are the traversals we're going to see. Okay, what are the traversals there, everything we want to talk about now one by one. First thing we're going to do, that is the how traversals are done in a tree. All right, so that is traversals in a tree. Now there are two types of traversals. One is depth first search and second one is breadth first search. One is DFS, that is depth first search. Second one is DFS, that is breadth first search. One is depth first search, second one is breadth first search. Now in depth first search, it is there are three depth first search thing is there. All right, one is inorder traversal, second is preorder traversal, third one being the postorder traversal. In breadth first search, we're going to talk about the level order traversal. In this, we're going to talk about the level order traversal. All right, going forward with the depth first search, that is the in-order travel. How? So in linear data structure, if you remember, in array or in linked list, there is one way of printing the data, right? Because that's a linear data structure. But here, various ways are there. That is the, either depth first search is going to be there or breadth first search is going to be there. In this four ways, we can print the same tree, binary tree, or whatever it's there. All right. Okay. So first thing we're going to see is DFS. DFS, all right, that is depth first search. In depth first search, we're going to see that is the first thing we have, that is Inorder traversal. Now, inorder traversal is a kind of traversal. What actually happens, how the traversal is being done, everything we're going to talk about that. All right. So we're going to create this same, this tree here for inorder traversal, and we're going to see how the inorder traversals are done. Okay, in the depth first search. Okay, we're going to talk about that. So in order traversal right now, just keep in mind that we're going to do LNR. Now what is this? We're going to use recursion here. So this means go to left side. Just remember right now, this is print the node. And this is going to be what? Go to the right side. Just remember this. I'm going to talk about what this mean actually. All right. Okay. All right. In order traversal, if it is there, let's try to create the that same particular tree. Let me copy it, and paste it. And I want to connect it also. Let's connect it. If I'm not giving connection for the leaf node, just understand it's a null. All right. And I have to give the values also. Let me give the values 10, 20, 30, 40, 30, 60, 70. Now, this inorder traversal is a kind of traversal how the nodes is going to be printed. Now, you can say that, okay, I'll print what? 10, 20, 30, 40, 50, 60, 70. That way I can print 10, 20, 40, 50, 60, 30, 70. That many ways are there for printing, right? Same this, this notes. So that's why we have 4 types we can print. That is inorder traversal, preorder traversal, postorder traversal, and level order traversal. Right now we are trying to see what is an inorder traversal. And in inorder traversal we are doing LNR, that is left part. We're going to go to the left side first. We're going to then print the node, and then we're going to go to the right side, then we're going to print it. All right. So LNR, we're going to do what? We're going to do recursively, we're going to print it. Here we're going to use the recursion. Okay. LNR means go to the left first, do the left side part, then you're going to do the right side part. So for every part there is going to be LNR. Okay. For 10, LNR is going to happen. That is the left recursion call is going to be there. All right. And for this also, there going to be some LNR. Okay. Now here null is there. Obviously, nothing is there, isn't it? Here also null is there. Let me draw it for you guys. Null. This one also null. This is null. This is also null. Null. This is also null. Now everywhere this recursive call is going to be. LNR is the recursive call. Sometimes left, then N is the printing, L is the recursive call of left side, R is for the right side, and this similar way LNR. Here is going to be happen. Here LNR. Okay. For this one also LNR. This is a right subtree. Okay. You can say LNR. LNR, LNR. These are the recursive call is going to be there. LNR, LNR, LNR. All right. Now, for 10, it is saying that go to the left side. Go to the left side. For 10, LNR means, L means left. Go to the left side, right? So, let us traverse to the left. We traverse to the left side. Let me take it in the L. Again we came to 20, then again it's saying go to the left side. You see LNR. Okay, if 20, again we went to the left side. We marked it at L as left side. We marked 20, that we already traversed 20, right? That is being done. Now for 40, again it says go to the left side. The left side. Nothing is there, so it's going to backtrack back to the 40. Nothing is there. Now it's going to print the note. What? Because L after L 40 is there what? n is there. N is what? That is 40. So what does n represent here? In the in-order traversal, you can see print the node. What is the print the node? That is 40. So 40 is printed first, comma. All right, means n is done. Now go to the right part of that. So okay, 40, in here, then it, try to do it again. It's going to backtrack to 40. Okay, L and R for 40 is everything is done. Now from here it's going to come back to left part is done for 20, so it's going to come back here. Now what it sees that left part is done. Now you have to do the node. You have to do, so node, print the node, because n means what? Print the node. We printed the node. This will get more understandable when I'm going to do the code. That time it's going to be very, very easy. Just try to focus what I'm trying to do, how it is backtracking, how it's going, that is everything. You try to see it. Okay, now n is printed, 20 is printed. Now go to the right part, right? So from 20 it's going to the right part. So left, for this, L is going to be there. So 50 L, go to the L, go it. For this is also done, nothing is there. It's going to backtrack 50. It came back to 50, right? So 50, when it came back, it has to print what? Node, right? So 50 is being done, right? Now after here it says again go to the left side. Okay, go to the left side, nothing is there. Back. Okay, n is, r is, all are done, because for the null nothing is there, right? So everything is done here. From here it's going to come back to 20. Here it's going to mark as right, done. For this right part done, left part done, node is printed. Okay, that's done. So for 20 left, L and R is done. Now it's from 20, it's going to backtrack to 10. We encounter what? 10, right? That's a node, n, right? So it's going to print that node, isn't it? So 10 is printed. It means I want to mark it as right at n. Now it says R, go to the right part of 10. R means go to the right side of what? 10. Okay, let's traverse. We are traversing. We reached what? 30. Go to the left part of 30. Obviously, we're going to go to the left part of 30. We went. Okay. All right. Now, after reaching here, again it's going to come down. Nothing is there. Backtrack. Okay. 60 is going to be printed as a node. Okay. Again, it's going to go to the right part. L and R. Right part. Backtrack. Okay. Nothing is there. From here, it's going to backtrack. We're going to get the node again. That is 30. Right. So node is printed. Go to the right part for this. Okay, for 30. All right, go to the right. Nothing there, come back. Nothing there, come back. All right, 70 is printed. All right, 70 got printed. Now it means this L and R all are completed, because it's a null is there. Okay, L and R is printed. From here it's going to backtrack. Okay, it's already done. R is done. From here node was already printed. From here it's going to backtrack here. Okay, so what? We are done with L and R. So this is the array, or you can say traversal we done. This is the traversal we done. So what is the in-order traversals? In-order traversal values are what? 40, 20, 50, 10, 60, 70, 30. 40, 20, 50, 10, 60, 30, 70. These are the values that is being printed that way. Okay, let me mark it as yellow so it will look, okay, this is how we reached from 10 to 20. This is how it is being reached. 30, 70, this, nothing is there. All right, all right, all right, all right. Then it is coming back this way, coming back this way. Okay, so this is done. This is what in-order traversal. So what it does is, in order traversal, I'm going to write the algorithm, so it's going to be very, very easy for you guys. So what we do in order traversal, in order traversal, the left subtree is visited first, followed by root node, and then the right subtree. This is what an in-order traversal. All right. Okay. What is the algorithm? If we try to write the algorithm, if I try to write the algorithm, what is going to be there? If I try to write the algorithm, in algorithm, it's going to be there as what? Traverse the left subtree, LNR, right? Traverse the left subtree using in-order traversal. Second thing would be visit the current node and print it. Third thing would be traverse the right subtree using in-order traversal. That is going to be the algorithm for this in-order traversal. Similarly, we're going to do for pre-order, post-order, and level order traversals, right? So when we apply that time, you'll understand better how we are doing it, right? You're going to understand everything, when you're going to match that time. Okay, this is in-order traversal. Second thing would be what are pre-order traversal. Now in pre-order traversal, we want to do what? It's going to be NLR. Now what does this mean? N means always we said that is print the node. Print the node. L means what? Go to the left side. What does R mean then? Go to the right side. All right. In pre-order traversal, what we're going to do is I'm going to write the the things. Let's say in pre-order traversal, the root node is visited first, followed by the left subtree, and then the right subtree. This is done in pre-order traversal. Okay. Now, what is actually the algorithm? Okay, let's write the algorithm, then we will draw it. Okay. What is going to be the algorithm for this? We already know what is going to be the algorithm, right? That we do what first? We want to visit the current node. Visit the current node and print it. Second thing would be what? Traverse the left subtree using preorder traversal. Third thing is traverse the right subtree using preorder traversal. Now this is the algorithm for this. Okay, then we're going to similar way we're going to create the we're going to create the similar tree, and we're going to say that okay, this is how it's the pre-order traversal is going to be created. Okay, let's do it. So we created this. All right, I will do what? This is connection with this is connection with this this. All right, so these are the connections that are there. All right, now what is going to be happening here? That is NLR. This is going to happen NLR. Okay, NLR, NLR, R. Null, 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 null. Okay, here also going to be NLR is going to be there. NLR, NLR. These are the recursive call is going to be there. Okay, NLR, NLR. Okay, so we will do how it's going to go back and how it's going to come. So all these things we're going to see. All right, now this is the root node. Okay, the values is going to be there. Let's enter the values here. Enter the value, that is 10, 20, 30, 40, 50, 60, 70. All right, now we going to traverse from 10. So n is going to be printed, right? That is node is going to be printed because n is there. So first I will take on n, but that is a node, so we know that whenever n, that is going to be 10 is going to be printed. All right, now after that is done, go to the left side. Okay, go to the left side. We came to the left side again. We encountered what? Node 20 is going to be printed. Okay, then node is printed. Go to the left side. We encountered 40 printed. Okay, it means node is done. Go to the left side. Nothing is there. Okay, backtrack. Go to the right side. Nothing is there. Backtrack. Okay, R is also done. All right, N is done, R is done. Come back to 20. Now go to R of 20, right? So you have to mark R. All right, we encountered 50. That is node. All right, print that. Print it. Then after printing, go to the left side. Is anything there for null values? No. Mark it. Tick, 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 tick. All right, come back. Go to here. Come back. All right. Okay, after coming back here, it's going to come back to 3. Again from here it's going to come back to 10, right? This left subtree is done, isn't it? We're going to move to the, because n is done, L is done for this, we're going to go to the right part. We get the node, print that node. After 50 is going to be 30, node printed. go to the left side, went, print the node, that is 60, printed. Okay, going here, coming back, backtrack, going here, coming back, backtrack here, left part is done, right part is remaining, go to the right part. We went to the right part, print the node, 70 is being printed. All right, okay, then come here, nothing is there, come back, nothing is there, come back, from here come back to 30. We already printed, left is done, right is done. Okay, come back to the root node. This is the pre-traversal. 10, 20, 40, 50, 30, 60, 70. This is the pre-order traversal we did. This is exactly the pre-order traversal. Similarly, we're going to do the post-order traversal. Post-order traversal. Third thing, post-order traversal. Okay, what is there in post-order traversal? That is going to be LRN. Go to the left side, right side, then print the node. This go to the left side, go to the right side, print the node, print the. All right, so in post-order traversals, left subtree is visited first, followed by the right subtree, and then the root node. All right, what is going to be the algorithm then? Then algorithm is going to be basically traverse the left subtree using post order traversal. Second thing would be traverse the right subtree using post order traversal. Third is visit the current node and print it, and print. This is the algorithm. Again, for that we're going to create the tree. That similar tree is there. We're going to create the tree and we're going to do it, right? So this is there. Let me create the tree. So this is the tree being created. Now I'll connect it. Let's connect it. Now we'll give the value also 10, 20, 30, 40, 50, 60 and 70. And obviously last, this will be pointing to null. This is going to be pointing to null, null, null. And this is what you're going to write in the code also. All right, null. All right, this is also null and this is also null. Okay, in the post order traversal it's going to be LRN. So we're going to write LRN everywhere. LRN, 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 All right. Now from 10, it's going to go to the left side first, right? Okay, it came to 20. Again, it's go to the left side of 20. That is 20. Okay, left side done. Again, it will go to the left side. Okay, done. Is anything there? No. Come back. Is anything there? Nothing is there. So do one thing. That is come back. Okay. After coming back, so left part is done, right? That is left part is done. Right part. Go to the right part. Anything there? No. Come back. Then print what? Print the node. That is 40 is printed first. Correct. So this is done. Okay, for this LRN is also going to be done. Okay, from here is going to come back to 20. So now go to the right part. 20 is not going to be printed at here because LRN is going to do the right part first, then it's going to be done, right? Okay, coming here. So go to the left part, coming, nothing there, come back. Here also it's going to come back. Before that it will go here. Okay, and from here it's going to print what? After 40 we encountered 50, so 50 is going to be printed. That's a node, right? That's a node. It means L R N, this is done. L R N, this is done. Right, we went, left part we went of this 50. Okay, for null there is no LRN, so it's already ticked mark. Okay, and N, that is 50, is printed, not ticked mark. Now we're going to come back to 20. So right part is also done for 20. Now node 20 is going to be printed. Print the node and tick mark it. So from 20 it's going to come back to 10. Now left part is done. Now it's going to go to the right part. Not node. 10 is not going to be printed, obviously, right? Because it's going to go to the right part. R is there, right? So I'll be tick mark the R. To the R. Okay, it says what? Go to the left part for first 30. Okay, gone, again gone. All right, here it will be gone, then it will come back from both because both are null. And one thing we have to do is tick 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 tick. Okay, then here you can see LRN, left part is done, right part is done, node has to be printed, that is 60 has to be printed. Print the 60, printed, print the 60, printed. Come back here, go to the right part of that 30, right? Go to the right part. Coming here, we are going to the right part. We go to the left part. This, okay, it's a null. Come back, going there, coming back. Okay, and this all are done. From here, then if left part is done, right part is done for 70, node has to be printed. That is the node, that is 70 is being printed. So 40, 50, 20, 60, 70 is printed. Now from here, if 70 is printed, coming back to 30. Now it will print because left of 30 is done, right of 30 is done, then 30 is going to be printed. So print the 30 here, printed 30. Then it's going to come back from 30 to 10 at the last. Left is done, so this is going to be marked. This is going to be marked to done. Now left part done. This is the left part. This left part of what? This is the left part of 10. That is already done. You can see, right? This is the right part of 10. That is done. You can see, right? This right. Okay, that is already done. Now node has to be printed, right? So print the node. Print the node, that is 10 is there. This is post order traversal. This is post order traversal. All right. Now this all three are the DFS implementation. Okay. All three that we wrote, that is what? DFS in DFS implementation using what? Recursion. or using stack data structure. Stack data recursion is the natural way to DFS since it follows the recursive nature of tree. This is the DFS implementations, 3 DFS implementation you can see, right? Now, second thing that is there, that is the BFS implementation, that is the level order traversal. Level order traversal is very easy, but for seeing when we try to visualize it, it's very easy, but when we try to implement it, that time we're going to use queue data structure. So in BFS, you remember, in graph also we're going to use for BFS queue, and for DFS we're going to implement it using stack, right? That is there, right? So second thing is the BFS, that is breadth first search. That is breadth first search. Now in breadth first search, we saw that one type is there that is called as level order traversal. I want to write them, and in there we're going to implement this, how that is done. Before that, we're going to understand what is level order traversal and how it's going to be printed. We're going to print that way, and you're going to understand, okay, this is the way to print it. This is the way to print it. All right, it's very visualize, but when you talk about that, how that is done, that's going to be bit tricky, you would say, but it is not. All right, so breadth first search is another tree traversal algorithm that explores the tree level by level. I'll talk about what is level 0, level 1, and level 2, level 3, level 4, right? That way it's going to print it. So starting the root node BFS visits all the nodes at the current level before moving on to the next level. This is the basic thing about BFS. Now what is the algorithm that is followed? Okay, so algorithm is very basic algorithm is there. We're going to use queue data structure. How that's going to be done? Okay, we're going to enqueue it and delete it. That's the thing we're going to do it. But let me write it how the algorithm is actually followed. All right, so we're going to understand the algorithm of it. Algorithm. So let's try to write it, the algorithm. First thing, what we're going to do is we're going to enqueue the root node into a queue. That is the first thing we're going to do. Second thing, we're going to use loop until the queue is empty, and in that we're going to delete it. So dequeue a node from the queue. Second thing is visit the dequeued node Third thing we're going to do is we're going to enqueue the left child, enqueue the left child of the dequeued node if any there. If it is not there, we need not to do that. Okay, and we're going to do what? Enqueue the right child, the dequeued node, if any there. Again, if any there. All right. So at the last, the traversal ends when all the nodes have been visited. This is going to be the algorithm for this. We're going to use the queue data structure. All right. So BFS is typically implemented using a queue data structure. It guarantees that nodes at the same level are visited before moving to the next level. Now for that we're going to take the tree also. For that we're going to obviously take the tree. So take the tree. All right, this way. Let's try to get the tree, create the tree, and how that is also going to see. All right. Okay, let's try to connect it now. Let's try to connect it. So it's going to have the value also. Let's give the values. That is 10, 20, 30, 40, 50, 60, 70. Right? These values are there. These values are there. Now we know that it is printed by level, right? So we're going to print that way only. So this is what level 0, level 1, right? Level 2. So how it should be printed? It should print like this: 10, 20, 30, 40, 50, 60, 70, right? Level 0, level 1, level 2. This is how it's going to be printed, right? This is level 0, this is level 1, this is level 2. This is how it's going to be printed. So we're going to print this one by one this way. Now this is the end of the traversals in a binary tree. Okay, now we're going to take this thing in the VS Code and we're going to understand how implementation is done. Then we're going to find the maximum value, minimum value, depth of that search. We're going to search it, we're going to sum the leaf nodes, we're going to try other questions. Lots of things is going to do. This is the, you could say, the explanation of this traversals that is being, this is the explanation of the traversal is being there. So we're going to implement these things together. We're going to do the lead code questions also. Lots of things is going to do, and that is going to make more clear and bind free. And there is not going to be single issue left after learning this topic. Hope you guys have understood. Now we're going to move and we're going to implement the same traversal things. We're going to create the tree also, that how the insertion we are doing. Normal way also we're going to do it, and by taking the input, taking input from the user, that way also going to take the nodes. Both way we're going to take it, and we're going to make it very dynamic code, that one, and we're going to use lots of functions we're going to get in there. Let's suppose, searching for maximum, finding maximum value, finding the minimum value, everything we will do that. Hope we're going to see over there. Thank you.